laws जो है copyright law में कुछ change हुआ है. So I would think of this as a topic of polity and governance. Energy, I have included it here. So apart from nuclear technology का एक जो बहुत important part है वो nuclear energy है. But apart from nuclear technology, the other advancements in energy production, which includes renewable energy or hydrogen-based energy, so that can also be added here. But since I also teach this topic in environment classes, so I'm not going to discuss the topics of one or two topics जहाँ पे technology पे ज़्यादा focus है. We will be talking about that. But you'll find that UPSC is asking many questions from this domain. Another domain of technology which has become very favorite of UPSC is technological solutions to fight environmental problems or social problems also. So again, these are things which you study in environment, so I've not included here in science and tech question. जैसे इस साल मेंस का question देख लो, water shortage and technological solution to tackle water shortage. Right? So it's a serious social problem, and how can technology help us in finding solution to water shortage? Or think of some questions in prelims examination this year. There was a question on membrane bioreactor. That is a technology which helps in water purification. Right? Or there was a question on fuel cell का end byproduct क्या है? Or there was a question on pumped storage जो है वो क्या है? There was a question on distributed energy जो है वो क्या है? Like which of the following are examples of distributed energy? So you find that this focus on advancements in energy production, energy storage, the focus on environmental technologies, like technological solution to fight environmental problems or social problem. This is another very important theme for both prelims and mains examination. But I have not included these topics here in science and technology class. I think that will be separately discussed in environment class if it already has not been. So let's start the discussion without spending more time into it. Let's start the discussion. For the past few year questions, I have a more detailed analysis in terms of, I also have linked to the newspaper articles and headlines where you can see that where a theme of the question was picked, or hopefully in fact maybe the entire question was picked, but definitely theme was picked. I do not have the same level of analysis for questions of 2015, 16, 17, right? But nonetheless, we will discuss about the basic concepts of almost each and every question. And if you have any questions, by the way, feel free to ask questions whenever you want. That's not a bar. So anyways, let's start the discussion with the first set of topic, basic sciences. Before that, one more thing, two more things. साइंस एंड टेक का जो बेसिक साइंस के लिए आप जितना अपने एनसीईआरटी में पढ़े हैं एंड उसके अलावा कुछ भी अगर इंटरेस्टिंग बेसिक साइंस में अगर हो भी रहे द न्यूज़ पेपर्स आल्सो कवर इट. यू आर नॉट सपोज टू रीड द ग्रेजुएशन एंड 11th 12th टेक्स्ट बुक ऑफ फिजिक्स एंड केमिस्ट्री एंड ग्रेजुएशन टेक्स्ट बुक फॉर दैट, राइट? सो व्हाटएवर इज गिवन इन न्यूज़ पेपर अबाउट सम एडवांसमेंट इन साइंस, नॉट टेक्नोलॉजी, देन दैट इज मोर देन इनफ फॉर प्रीलिम्स और मेंस एग्जामिनेशन. सो दैट इज व्हाई एक्सेप्ट 9th and 10th एनसीईआरटी I do not recommend any textbook, standard textbook to do this topic, because most of the questions will be doable by the Hindu or Indian Express. This website has been now like this. Compared to other topics, science and tech prima facie may seem like a more difficult topic, but it is also a more attemptable topic. So if let's say there are 10 questions or 12 questions in prelims examination, then you should attempt 90% of the questions from science and tech, and you should also get 90% accuracy. So if there are 10 questions, then you are attempting 9 and you are getting 8 correct. That should be your goal, and it is very much a doable, achievable goal, irrespective of your educational background. Because a lot of students are fearful of this subject, that I haven't studied science after class 10th and 12th, and it doesn't matter. You just have to put into more effort, right? That's it. You have to put into more effort. But ऐसा कुछ भी aptitude नहीं चाहिए जिसके लिए आपको graduation में अगर अपने science, engineering, medicine, and also some of the most advanced scientific experiments which are happening across the world. Okay, so there is a question on, this is a current affairs inspired question. The term end arc, sometimes seen in the news, is the name of, this is, if you know it, you know it. If you do not know it, then do not need to take any guesswork here, right? So ये बहुत simple है, that this is an underwater observatory to scientifically study the Arctic region, right? So when you look at the responsibility of ministries in India which have bearing on scientific and technological development, then 3 ministries clearly stand out. Apart from that, 2 more departments which directly come under Prime Minister clearly stand out. So you have Department of Space and Department of Atomic Energy directly working under Prime Minister. They do not work under any ministry. But apart from that, there are 3 ministries. The first is Ministry of Science and Technology, and Ministry of Science and Technology has 2 very important departments: Department of Science and Technology and Department of Biotechnology. And then you have the second ministry is Ministry of Electronics and Information Technology, which again has many departments. Department of Telecommunication or Department of Electronics is the most important department here. And then you have Ministry of Earth Sciences. So Ministry of Earth Sciences is also very important. And in few domains, in 3 domains, they have the primary responsibility. The first is weather forecasting and climate modeling. तो जो भी weather forecast होता है जो आप देखते हो, जैसे IMD जो Indian Meteorological Department, that works under Ministry of Earth Sciences. And then oceanographic studies, जो भी ocean sciences में study हो रहा है, about wave patterns and ocean currents or increase in sea surface temperature, all of that will be again done by Ministry of Earth Sciences. And third is polar research, all type of polar research. So our research stations at Antarctica, such as Bharti and Matri, and our research station at Arctic, such as Himantri and INDARC. So INDARC is not a research station. INDARC is more of many instruments which we have placed underwater. The goal here is to understand about Arctic sea ice in more detail. So it's not like Bharti or Matri or Himantri, which are research stations where Indian scientists are working there and overall trying to understand about knowledge of poles and how poles affect the Earth's climate system. So INDARC is more of many instruments placed underwater, trying to understand about the salinity of sea ice, melting of sea ice, the impact of sea ice on overall Earth climate. Right. So this is what INDARC is, not as such a research station, but an underwater observatory to scientifically study Arctic region. So इसका आंसर है, and it should only be answered if you know about this. If you do not know about this, then maybe I think that it can be a challenging question. The next question is, I specifically remember why this question was asked by UPSC. In the context of modern scientific research, consider the following statements about IceCube, a particle detector located at South Pole, which was recently in the news. Why this question was asked? Because around the same time, Government of India had proposed that we are going to make Indian Neutrino Observatory in Tamil Nadu. And there was a lot of protest against this. In fact, some protest is even there by Tamil Nadu government. At that point of time, the protest had कोई बिना सरकार का protest था, that जो artificial neutrino है, it is dangerous, it has very dangerous radiation, can cause diseases. All of those things were there, which are simply not true. Right? So there was a lot of protest against this construction of Indian Neutrino Observatory. And then newspaper articles covered some of the most important neutrino observatories of the world. And the biggest and the largest neutrino observatory is IceCube. And that was also covered in newspaper. And then UPSC picked this theme and made a 3-statement question on it. Okay. It is the world's largest neutrino detector encompassing a cubic kilometer of ice. It is a powerful telescope to search for dark matter. It is buried deep in the ice. यहाँ पे second statement थोड़ा सा problematic इस sense में है that I should not use the word telescope, because the meaning of the word telescope is very precise. Telescope is more about gathering light. भले कोई भी light हो, it can be visible light, ultraviolet light, radio wave also. But nonetheless, this part is true, that it aims to search for dark matter. And UPSC did consider that second statement to be correct. And third is again correct, it is buried deep in the ice. And uska ek simple sa karan ye hai. So let me show you what this ice cube observatory looks like. If you go to Antarctica, Antarctica is really huge, but at one place in Antarctica, on the surface you'll find this research lab, but the actual scientific instruments are up to 2.5 kilometer deep inside ice. So on the surface, the part which you saw, that is the part, but the actual instrument is actually, all of these instruments are placed quite deep inside this ice. And the reason is simple. Neutrinos are mysterious particles. Neutrinos are second most abundant particles. They do not have charge. Since they do not have charge, they are not affected by electromagnetic force. They have almost zero mass. I will not say that they have zero mass, but they have almost zero mass, and they travel with very high speed. They're also not affected by strong interaction, another fundamental force which exists in nature. So they're only affected by two interactions. First is gravity. Everything is affected by gravity. And second is weak interaction. There is a fundamental interaction called weak interaction. The best example of release of neutrino in a nuclear reaction is a reaction called beta decay, which you have learned in your radioactivity classes. That certain nuclei, when they're not very stable, then they disintegrate into lighter nuclei. Not disintegrate, decay into lighter nuclei. Think of carbon-14. Carbon-14 is a radioactive isotope. It emits beta particle, which is electron, but it also emits neutrino. Right? So this is a very good example of one of the way, in fact, it releases anti-neutrino. It doesn't matter. It's a very good example of a reaction which is producing neutrino. But the most prevalent reaction which produces neutrino is nuclear fusion reaction. That in the core of star, when hydrogen nuclei fuse together and form helium, they also produce neutrino. So stars are the biggest source of neutrino. So stars release a lot of light. Light is made of photon. So photon is the most abundant particle. But the second most abundant particle in the universe is neutrino. And since neutrino is not affected by charge, is not affected by strong interaction, every second, all of us are being crossed by billions of neutrinos. And we are not affected by it, and those neutrinos are not affected by it. And most of these neutrinos were produced in the core of stars across the universe. And these neutrinos can travel lights of years without being affected. They can cross entire Earth without being affected. And that is why all of the neutrino detectors you'll find that either they're deep into water, they're deep in the ground, in this case deep in the ice. Because most of the particles, these microscopic particles, electrons, protons, alpha particles, neutrons, all of these particles will be filtered out by different layers, but neutrinos will not be able to filter out. So this setup are often located underground because now whatever we are detecting neutrinos. So that is third part we can appreciate this, that it is buried deep in the ice. And even today, the first part is correct. Even today, although this question was asked in 2015, but this first part is correct even today, that it is actually world's largest neutrino detector. Okay, why second is correct? Dark matter is a concept. Dark matter, and I will repeat, it is only a concept. We actually do not know if it is real or not. Science progresses by developing some hypothesis, that there is some experimental data you have come across. You're trying to explain that data, and you develop a theory about it. And then this theory can be proven wrong and can be proven right by more subsequent experiments, right? And I often give these examples of the discovery of Neptune and the problem with Mercury. When scientists in 20th century, with help of powerful telescopes, looked at all the planets, they found that the orbit of Uranus is not exactly what Newton's law is predicting. Remember, with help of gravitational law, we can explain orbit of all the planets. But the orbit of Neptune was not exactly what Newton's law is saying. There are two possible explanations. Either Newton is wrong, or there is something else which we have not accounted for. So a group of scientists thought that the second is true, that there is something else which we have not accounted for. And they thought about that maybe there is another planet nearby, which is very heavy. And that planet is disrupting the orbit of Uranus a little bit. And they looked at how much that disruption is happening. And then based on that, they did a mathematical calculation that where this planet should be, and how far away it should be, and in which direction it should be. So they did all this calculation, they took a telescope, looked into that direction, and found Neptune. So Neptune actually was discovered first on a piece of paper with help of some mathematical equations. And now we know that of course it is there. Same thing had happened for Mercury also. That Mercury orbit was not exactly what Newton's law is predicting. So many scientists thought the same, that maybe there is a planet near to Sun compared to Mercury. And since it is so close to Sun, in the brightness of Sun, we are not able to see this planet. And maybe this planet is affecting the orbit of Mercury around Sun. But Einstein thought otherwise. Einstein thought that Newton is not correct. Einstein thought that Newton's theory of gravity needs a modification. And he developed this better theory called general theory of relativity, which by the way, there was a question asked by UPSC on that topic also. And the general theory of relativity now provided this insight that why Mercury orbit is a little bit different than what Newton is saying. So we have now a better theory of gravity, which we call general theory of relativity. Right? So that is how science progresses. That either you think that you do not know everything, some data is missing, or you need to find a better theory. So when we look at the movement of stars around the center of galaxy, so think of Milky Way galaxy. At the center of Milky Way galaxy, there is a supermassive black hole called Sagittarius A. And the same way, Sun allows planets to revolve around it. The supermassive black hole is so dense and massive that these billions of stars are revolving around the center of galaxy. Right? So if I apply Newtonian's theory or Einstein's theory also, the stars which are very far away, they should revolve much more slower. And the stars which are very close to the center of galaxy, they should revolve much more faster. The same way, Earth and Venus revolve faster than Jupiter and Uranus and Neptune. So we can think of the same, because after all, the mathematics is the same. So when people collected the data about the revolution of stars, they found out that even these very distant stars are revolving as fast as stars which are very close to the supermassive black hole. So this is now an anomaly. Our existing theory cannot explain that why is it happening. And there are many such anomalies. I have told you the most famous gravitational anomaly, but there are many more. And then scientists are divided into two groups. A group of scientists who believe that the Newton's gravitational theory, it needs modification. Einstein's gravitational theory, it needs modification. But majority of scientists believe that there is a group of particles in the universe which have mass, but they're chargeless. And since they're chargeless, they're not affected by electromagnetism. They're also not affected by, maybe they're also not affected by strong interaction. But since they have mass, they can cause gravity, and they're affected by gravity. So this gravitational anomaly you see is because of this matter we call dark matter. But dark matter is only a theory. Till date, it remains a theory. We do not know if dark matter is actually out there. So why neutrino detectors can help us in knowing about dark matter? Because one of the most famous theory that if there is dark matter, then what it is? And the most famous theory is that it is also a matter which is only affected by weak interaction and gravity, same as neutrino. So if we understand about neutrino, maybe that will allow us to know more about dark matter. So that is why often whenever about neutrino detector, if there is a statement that it also aims to know more about dark matter, that statement will be correct. But here I will repeat this word telescope is problematic. But nonetheless, answer is first, second, and third. 1, 2, and 3. If you have question here in this topic, you can ask questions. Let's go to the next question then. 3, 4 questions together I can discuss. This theme of gravitational wave has been asked by UPSC many number of times. What is the purpose of evolved laser interferometer space antenna? The answer is to detect gravitational waves. B is the correct answer. Recently, so that was 2017, this is 2019. Recently, scientists observed the merger of giant black holes billions of light years away from the Earth. What is the significance of the observation? Gravitational waves were detected. So here also B is the correct answer. And in 2020, the experiment will employ a try of spacecraft flying in formation in the shape of an equilateral triangle that had sides 1 million km long with lasers shining between the craft. The experiment in question refers to that ELISA which UPSC asked earlier in 2017. So the answer here is D, evolved LISA, which aims to detect gravitational waves. So all of these questions are related to each other. Gravitational waves have been in news a lot, and even though again this topic is prima facie a difficult topic, but UPSC is not asking some like great technicality here. They're simply asking about what this experiment is or what it aims to do, like things like that. So let's briefly talk about all of these things together. In fact, one more topic I can discuss together, 4 questions I can discuss together. There was a question asked by UPSC in 2018, I think. Consider the following statements. Light is affected by gravity. The universe is constantly expanding. Matter warps its surrounding space-time. And then the question is that which of the above is our predictions of Einstein's general theory of relativity often discussed in media. UPSC ने last में भी लिख दिया था कि ये ऐसे ही नहीं पूछ रहे हैं. This is actually discussed in media. Right. So anyways, this was actually discussed in media. They are not lying. This was discussed in media. And why this was discussed in media in that year? I'm going to discuss that also. Answer is D here. 1, 2, and 3. The correct answer will be 1, 2, and 3. Okay. So let me briefly now explain all of these topics together. So why Einstein is considered one of the greatest scientists along with Newton. So 2 of the brightest minds which this planet had seen will be Sir Isaac Newton and Albert Einstein. Right. So Newton, even though many of his theories are have been modified, but he developed things when there was almost no knowledge. Like he developed everything from grassroots level, and even though many of his ideas have been modified, he's considered the brightest mind. But Einstein, already science was well established, discipline, scientific method was well established, but Einstein was able to imagine things which people were not able to do that. And when Einstein gave his theories, so he did many things, but he's remembered for the 2 things. The first is called special theory of relativity, and the second is called general theory of relativity. And when he gave his theories, very few people understood it, and even fewer people thought it to be correct. And then there was no way to confirm if he was actually whatever he was saying is correct or not. Now we know that almost everything he said was correct. In fact, he said everything correct. The only thing is that few things he was not able to figure out. But the things he was not able to figure out, even today we have not been able to figure out. What are those things he was not able to figure out? So anyways, Einstein gave his first theory in 1905, which is called special theory of relativity. Special theory of relativity is essentially based on a fundamental law of physics, that speed of light remains the same in all frame of reference. Right? So there are certain laws of physics which are independent of frame of reference. Just say, if I say that energy is conserved, then for everybody energy is conserved. No matter if I'm here or somebody's on Mars or somebody's traveling with very high speed, doesn't matter. Energy is conserved, energy is conserved. It doesn't matter upon your frame of reference. Few things matter on your frame of reference. For example, if I ask you that how far you are, right? तो अब देखना पड़ेगा कि किसके हम respect में बात करें. For you, for me, आपका coordinate कुछ अलग है, उनके लिए कुछ coordinate अलग है. So there are few things which depend upon in which frame of reference you are. But then there are things which do not depend upon your frame of reference, right? So even before Newton, there was a scientist named Galileo. You all know Galileo as inventor of telescope, although he did not, but he did use it to a very large extent. So Galileo talked about this idea for the first time, that there are certain laws of nature which will remain the same, independent of the observer. फर्क नहीं पड़ता है कि वो observer है कौन से frame of reference में है. These laws will be the same, right? Newton said the same thing. Einstein also said the same thing. So Einstein did not say anything new in that statement. What he said, the second statement that was new, that speed of light is one of that law. So first, Einstein's special theory is based on 2 postulates. The first postulate is that laws of physics, they are independent of frame of reference. And the second postulate is that one of that law is speed of light, which essentially means that if there are, let's say, 2 objects A and B, 2 observers, moving with same velocity in a straight line, then I will say that the relative velocity is 0, isn't it? Just for example, we all are moving because Earth is rotating and revolving. But since we all are moving with same rotation and revolution, then we are at rest with respect to each other. So this is what it logically makes sense, that relative velocity in this case will be 0. In this case, however, when this is velocity in 2 different directions, then A will measure velocity of B as 2 times v, and B will measure velocity of A as 2 times v. This is called relative velocity. But then Einstein says that this needs a little correction. Even that 0 is not correct, but it is almost 0, so we can ignore it for lower speed. But Einstein said that if your speed keeps on increasing, then whatever logical intuition you have developed, that is simply going to be wrong. It's not going to help you. So Einstein says that if this v becomes c, that let's say there are 2 light photons, and photons travel with speed of light. Speed of light is often shown with this constant, small c. C is 3 lakh kilometers per second. And 2 photons in the opposite direction. Then as per our logical intuition, the relative velocity here should be 0, and the relative velocity here should be 2 times c. Einstein is saying that both are wrong. Here also it will be c, and here also it will be c. So speed of light, that remains the same in every frame of reference. And that does not make sense. But then Einstein says that it happens because you have till now thought of space and time as 2 independent things. But they are not. Nobody had thought of this. Right? Newton never even thought of this. In fact, before Einstein, nobody thought of this, that time is dependent upon space and vice versa. So what Einstein now says, that if something is traveling with, let's say, very high speed, half of speed of light, उनके लिए जो length है वो कम होगा. उनके लिए, so we use things like length contraction. जैसे मान लो अभी तक हमने ये पढ़ा था that अभी हमने एक point discuss किया that if I, let's say this is my some frame of reference, there is some observer O here and there is frame of reference observer O dash here, and let's say that on one point they will not agree to, that is point का coordinate क्या है, ये point कहाँ कितना दूर है, they both will disagree. But अभी तक हम ये तो मान के चल सकते हैं ना कि अगर दो point का distance निकालना हो तो दोनों बोलेंगे कि डिस्टेंस मान लो कुछ L है, they both will measure this as L, right? So for example, in the question I asked that what is his coordinate, and that answer is dependent upon where I am and where you are. But if I have to say that what is the distance between these two people, then no matter who measures it, the distance will be same. Einstein says that no, it will not be same. Einstein says that the distance will differ. The distance will depend upon how fast you are moving. So your speed decides the distance between 2 points. And the same thing, if I drop this pen and I caught this pen in my hand, then let's say this event happened in 1 second. So before Einstein, everybody will say that this event happened in 1 second. Everybody will measure this 1 second. कोई भी measure करे universe में will measure this event in 1 second. Einstein said that this is also false. That this is not 1 second. This depends upon how fast you are moving. If you are moving very fast, what time you will measure? Maybe it is 1 second in your frame, but somebody who is stationary, somebody who is not moving fast, will measure the same event in separate time. So the consequence of light being at constant speed in all frame of reference is that space and time, which we think of separate entities, that we live in a 3-dimensional space, and then time. So now Einstein says that we actually live in a 4-dimensional world, where 3 dimensions are spatial coordinate, but the 4th dimension is time. Although there is very weird property of time that while in space I can go up, down, left, right, sideways, but in time I always seem to go in forward direction. I cannot go back in time. So in that way, time dimension is a little different, but space and time are very much dependent upon each other. So this is what Einstein says in special theory of relativity. It leads to what we call length contraction. If I have to talk about the consequences of special theory of relativity, it leads to what we call length contraction, that the measurement of length will not be same. It leads to time dilation. In fact, it also leads to E is equal to mc squared. That same law which says space and time are not independent of each other, the same law also tells us that mass and energy are also not independent of each other. Mass and energy are very much dependent upon each other. And I'm very sure that you have come across this equation E is equal to mc squared somewhere. All of that is consequence of special theory of relativity. But then 10 years later, Einstein published another paper. In 1915, he published this paper called General Theory of Relativity. And in General Theory of Relativity, now he provided a better theory of gravity. So General Theory of Relativity का जो सबसे fundamental जो point है, that not only space time are same, like they're dependent upon each other, but they're affected by gravity. That a very heavy object, it warps space time around it. The same way, for example, let's say आपने किसी surface पे बहुत tightly कोई cloth बांध रखा है, and you put something very heavy onto it, and it causes a warp here, right? So Einstein thought that now imagine the same thing in 3 dimension or 4 dimension for that matter, because space time is 4 dimension. An object which is very heavy will warp. So around this object, the space time interval will be less, and as we go further and further, it will be more and more. So what you think of a gravitational force, you think of gravity as a force, but in Einstein theory, it does not have to be a force. In Einstein's general theory of relativity, gravity may not be a force. Gravity simply be a consequence of curvature of space time, which is shown here. This is a more heavy object. This is a less heavy object. That more heavy object causes a bigger curvature compared to a less heavy object. And when this object comes in this curvature, then it starts moving in this curvature. And this is what Einstein says that causes what we call gravity. So not only space time are same thing. Space time is affected by gravity, which means that the length interval I'm going to measure on sun, what is 1 centimeter on sun is not 1 centimeter on earth, and what is 1 second on sun is not 1 second on earth. So time progresses differently depending upon how much massive object you are, where you are exactly. So around a black hole, time will progress differently. Around a very heavy star, time will progress differently. Around an average star like sun, time will progress differently, and around earth it will progress differently. So it's not that space and time are just dependent upon each other, or they are same thing. Space-time curvature is essentially dependent upon mass. So this is what Einstein says in his general theory of relativity. And general theory of relativity led to many consequences. Of course, the first is that space-time is affected by gravity. So we have studied that light always travels in a straight line. हमने पढ़ रखा है. But if light is traveling in a straight line in space-time, but what if space-time in itself is curved? Right. So if space-time in itself is curved, you'll not find light traveling in a straight line. You'll find light bending towards gravity. Whenever there are very massive objects, because of those massive objects, even light is going to bend. Right. So light is affected by gravity. That was the first statement, which was asked by UPSC. That is the correct statement. Why? Because this heavy object has warped, folded the space-time around it. And light is actually traveling in a straight line. The problem is that space-time in itself is curved. And because of that, we are going to perceive this light that it is being bent by gravity. So that third statement was also true, that matter does warp space-time around it. In this case, I have shown this picture of a phenomena which is called gravitational lensing. Gravitational lensing occurs that मान लो एक बहुत दूर galaxy है, ये Earth है, some billion light year away, there is a galaxy. This galaxy is so far away that the light coming from this galaxy before it can reach to Earth will be so faded that we'll not be able to see this galaxy. Right? That's very obvious. कोई भी बहुत powerful optical instrument है, but every optical instrument has some resolving issue that बहुत ही dim अगर light हो, it will not be able to find the image. But just by chance, there was cluster of galaxy or galaxies in between. And the same way, a lens can converge light. आपने पढ़ रखा है? Remember your class 9th or 10th optics class? That a convex lens or concave mirror converges light. So the same way, a lens converges light. Because of the gravitational distortion here, because of the curvature of space-time, this light can converge now. And because of that convergence, a telescope here will be able to see this galaxy very, very far away. So this phenomena is called gravitational lensing, which is a direct consequence of the fact that light is affected by gravity. Einstein theory also explained that black holes can exist. Einstein theory also came to a conclusion that universe is expanding. And when this was a conclusion made by his theory, Einstein thought that this is not correct. Einstein thought that there is something wrong with his theory. It needs correction. And later, when scientists actually looked at the distant galaxies with help of telescope, and they found those galaxies moving far away and far away from each other, and this was confirmed that universe actually is expanding. So Einstein's reservation about his theory was proven wrong. His theory was proven right. that universe is expanding. So, and by the way, why this topic was covered in media? Because some 100-year had occurred of general theory of relativity, particularly about the Einstein statement where he considers his life biggest blunder was to doubt his theory, that he had doubted his theory, and then he goes on to say that that was his biggest blunder. Right. So in any case, and that is why this was covered in detail in newspapers, and theory of relativity was covered in more detail, and UPSC made a question on it. So there are many consequences of general theory of relativity, that matter warps space-time, black holes can exist, light is affected by gravity, gravitational lensing, but it also leads to one more conclusion, that gravitational waves can exist. 3 questions on gravitational wave in last 10 years. So gravitational wave exists. What is a gravitational wave? Think of a wave with some sort of vibration. If it is a sound wave, it is vibration of air or some other medium. If it is a light wave, then it is electric and magnetic field, which is vibrating. Electromagnetic field, propagating in space. But when I use the word gravitational wave, it is not about propagation of something in space. It is space-time curvature in itself is vibrating. That whenever gravitational wave passes through, it means that space-time curvature is coming closer to each other and going away from each other. So it is not something passing through space. It is space-time curvature changing in a periodic manner as this gravitational wave passes through. This occurs because of very high massive objects if they're accelerating, or a sudden production of huge amount of energy which can produce gravitational wave. Theoretically, even sun can produce gravitational wave, even earth can produce gravitational wave, theoretically, but that gravitational wave is going to be so weak that we will not be able to detect it. But there are events in universe which are called cataclysmic events, like pralayakari events. Two black holes आपस में merge कर गए, two huge black holes, and they merged together. A very heavy star went supernova, started exploding, produced so much of energy that for a brief moment it outshined the entire galaxy. This event is called supernova. So these events can produce now the scale of energy, and the gravitational wave which will be so powerful that this can be actually intercepted even though they occurred millions of years ago. So the question which was asked by UPSC, billions of light years away from the Earth, what is the significance of the observation? That produced a gravitational wave which was detected on the Earth, and it was detected with help of a setup that is called LIGO, Laser Interferometer Gravitational Wave Observatory. And this topic is important because as of now, Government of India has given approval of a LIGO setup in India. It is an under construction facility in Hingoli district of Maharashtra. The topic is very important. LIGO के बारे में that Government of India भी approval budget सब कुछ finalize है. The plan is that by 2030 we will have our own LIGO experimental setup which is going to collaborate with other LIGO setup of the world. So what is this LIGO setup? LIGO setup essentially is this L-shaped 2 big arms. I may have a picture of this. I do not have a picture, actual picture, but this will be this 4 kilometer big arm. There will be mirrors here. These mirrors will, and there will be some light producer here. So it is going to produce light, but there will be a mirror here. And this mirror will divide this light into 2 parts. Half of the light will go here, half of the light will go here. This mirror will have 100% reflectivity. So this light will be reflected from here, this light will be reflected from here. And this 2 light will now interfere together. Hence the word laser interferometer. It is an interferometer, it is going to cause interference of light. Now, since this distance is same, 4 kilometer, this distance is same, this 2 light is going to come back at the same point, and that will cause some sort of interference pattern. But if this distance changes, then this interference pattern will be some different pattern. Now, how can that distance change? This distance can change, let's say, because of some thermal changes. Temperature अचानक से बढ़ गया and thermal expansion हो गया, या बहुत कम हो गया, thermal contraction हो गया. So we should choose first a place where temperature difference is not that much. We should choose the materials which do not expand and contract that much with temperature, and even then we need to isolate them in a way that the heat transfer between the setup and the outside is very less. So we can remove that part. The second problem, which can increase the length or decrease the length, can be earthquake or landslides. Then choose the setup in places which are not prone to earthquake. And in any case, we can always detect earthquake, that if earthquake has occurred or not. Or there can be a way how this length can change is if a gravitational wave has passed by. Because if a gravitational wave has passed by, remember, gravitational wave causes space curvature to come together, space interval to come together and go away together. So anything, whatever it passes through, their length changes periodically. The length increases and the length decreases. So if a gravitational wave has passed by, then this arm length will decrease and this arm length will increase. And the next instant, this arm length will decrease and this arm length will increase. This will be a very specific interference pattern. And by the way, just in case that you still want to ensure that कोई और variable के कारण ना हुआ हो, then have more setups. Have one in Louisiana, have one in California. So this was a setup made in America. And in 2015, it announced that we have detected gravitational wave. So it was theorized by Einstein 100 years ago, 1915, but it was discovered for the first time in 2015, 100 years later. And the person who thought of this setup, Kip Thorne was given Nobel Prize in Physics just next year. In 2016, Nobel Prize was given to Kip Thorne. Kip Thorne is the person who also wrote the script of movie Interstellar, if you have watched that movie. So anyways, this is LIGO setup. अब इसका एक और जो यूरोपियन स्पेस एजेंसी का एक बड़ा ग्रैंड सा प्लान है, and that grand plan is evolved LISA. कि अर्थ पे, let me complete this, I will answer questions. What European Space Agency has thought that ये 4 किलोमीटर का जो डिस्टेंस चेंज होगा फिर भी बहुत कम होगा. So what they plan to do, they plan to launch 3 satellites with again mirrors around sun now, not around Earth. And these 3 satellites will make 3 sides of an equilateral triangle. तो इनका पोजीशन सन के अराउंड ऐसे होगा that all the time they are going to make an equilateral triangle, और equilateral triangle का जो साइड होगा वो कुछ 1.5-2 मिलियन किलोमीटर का होगा. And all the time they're going to send light signal to each other. If a gravitational wave has passed by, then this 4 million kilometer length will change much more compared to a 4 kilometer. So 1 million kilometer length will change much more compared to 4 kilometer on Earth. So that is the plan of European Space Agency, and this experimental setup is called ELISA. अभी तक ये launch हुआ नहीं है, ये 2030 से 2035 तक launch होगा. So the answer here is D, that employ try of spacecraft flying in formation in the shape of equilateral triangle. In fact, it is not even 1 million; it is more than 1 million kilometer long. The answer is D here. So all of these questions are based on similar set of concepts of gravitational wave or Einstein's theory of relativity. One more thing which you should know about gravitational wave is that they travel with speed of light. Hanji, you had a question. Because it travels, gravitational wave travels with speed of light, so you can say that almost same time, if not same time. Japan और India के बीच में कितना distance है? Okay, so that is why more than one setups is required. That if a gravitational wave has passed by Earth, then all LIGO setup will show the exact same interference pattern. The reason why there are more than, and by the way, it's not just in Japan and India and US, it is also in Italy, it is also in Germany. And if a gravitational wave has passed by Earth, then all of the setups will show the same interference pattern with a difference of fraction of second, because gravitational wave travels with speed of light. So then we can ignore or we can filter out that earthquake part also. Right? The earthquake, har jagah, same type earthquake where that is again not going to happen. Any other question? Okay, so LISA Pathfinder was a plan launched by again ESA to explore that if it is possible or not. That एक बड़ा setup करने से पहले आप छोटे-मोटे जो experiments करते हो. So the answer is yes. That evolved LISA is their main plan, but before they can launch evolved LISA, they sent some experimental setups that is it possible, and all of those experiments were called LISA Pathfinder. So the answer is yes. But इस question का answer जो है evolved LISA है. Any other question? Which one? C option, sorry. C option wormhole option है. No, we do not have any setup to detect a wormhole. Wormhole is a place where space-time is folded in a way that I can travel millions of kilometers in like matter of fraction of second. That gravitational anomaly is so high. Often people use in movies जो दिखाते हैं तो मैं आपको दिखा देता हूँ कि जो space-time curvature अगर ये है तो some gravitational anomaly allows this curvature to fold like this. So if I have to go from this point to this point, then I have to take a path, right? But if because of gravity the space-time is folded in a way, then with help of this wormhole I can go from this point to this point in matter of second. This is allowed by Einstein's theory. Wormhole theoretically can exist, but do they exist? First of all, we do not know. Do we have a setup to determine that? Not at all. Yeah, if this happens, it will be because of gravitational anomaly of some massive object that is there. Or maybe some other way we have figured out how to create artificial gravity so powerful that it can produce a wormhole. That is the plot of Interstellar movie. Okay. That's a junk light. That's a separate thing. That's a separate thing. Okay, so let's go and see the next question. There was one more question here. The term event horizon, singularity, string theory, standard model are sometimes seen in the news in the context of. The answer here is observation and understanding of the universe. So ऐसे question का best part ये भी एक होता है UPSC बहुत सारे terms throw करती है. And even if you know about one of them, you can get the answer. But if you do not know about any of them, then you should not attempt such questions. That if you have no idea that what these words mean, then you simply should not attempt such questions. But these are very popular words. All of the words which are mentioned here, they're very popular. They're covered by news. साल भर अगर आप newspaper पढ़ोगे तो आपको इन चारों में दो word तो पक्के से मिल जाएगा. या हो सकता है चारों भी मिल जाए. तो है क्या एक बार briefly देख लेते हैं without like going into a lot of detail. Singularity is this concept in cosmology, in physics, that you can think of singularity as all of the mass concentrated in zero volume, which essentially will mean infinite density. And in mathematics, infinite is good. In physics, it is not good. No physicist will say that there is somewhere there is some infinity. Singularity is considered. So, जो हमारा existing laws of physics है, Einstein का जो theory है, as per Einstein theory, singularity exists at the center of black hole. Or as per Einstein theory, universe started from singularity. So that Big Bang which we say, that started from singularity. Infinite, densely object exploding at very high energy, leading to formation of universe as we know of. Right? So this only tells you that we do not understand singularity. So I said that Einstein was not able to figure out few things. This is one of those things. So हमारे जो existing laws of physics हैं, they completely break down the moment we go at the center of black hole. Right? So the understanding of singularity will perhaps allow us to understand more about evolution of universe. So, but rest of the black hole we still can at least mathematically describe. You cannot mathematically describe singularity, but rest of the black hole you can mathematically describe. That if this is black hole, then there is a region around black hole which is called event horizon, and inside event horizon, the escape velocity is more than speed of light, which essentially means that even light cannot escape. And by the way, Einstein का जो special theory of relativity है, उसका एक और consequence ये भी है, that nothing can travel with faster than speed of light. There is a maximum barrier, and that barrier is speed of light. And only massless particles can travel with speed of light. The moment there is some mass is also not constant. As you travel faster, your mass increases. So there are certain particles which are massless particle, and those massless, such as photon, they are the only particles which will travel with speed of light. So proton can never travel with speed of light. Electron can never travel with speed of light. Neutrinos are almost massless, so their speed will be very close to speed of light, but again not speed of light. But it will be like 0.9999999 in C ऐसे कुछ होगा, not exactly speed of light. So anyways, inside event horizon, the escape velocity, the gravitational force is so powerful that escape velocity is more than 3 lakh km per second. On Earth it is 11.2 km per second. Right? Her object depending upon the mass, right, or mass कितना concentrated है, escape velocity is decided. Black hole की case में it is more than 3 lakh km per second. So this region around black hole is called event horizon. The moment you are part of event horizon, you cannot escape. There is no possibility of any escape after you are part of event horizon. Okay. The two more words which are given is string theory and standard model. So people have always wondered about that, are we made of something fundamental? That हम जो चीजें देख सकते हैं अपनी आंखों से, but अगर हम चीजों को divide करते चले जाएं, that do you come across at some juncture where you cannot see further, you cannot look further. So I will call that as the fundamental scale of the universe. Right? जैसे we know that whatever matter we know, it is made of molecules. ये सबने पढ़ रखा है. We also know that all molecules are made of atoms. We have learned that also. We know that all atoms are also made of these three particles we call neutron, proton, and electron. And we know atomic structure that neutron and proton are at the center of atom in a very dense object called nucleus, while electrons can be thought of as revolving around nucleus. ये सबने हमने पढ़ रखा है. But then we ask a question that have we found fundamental particles? Have we found that I cannot go any further? That everything is made of neutrons, protons, and electrons. तो अभी तक जो हमारा अंडरस्टैंडिंग है, जो हमारे पास प्रॉपर एविडेंस है उसका, we have experimentally confirmed it that electron is a fundamental particle. That electron actually is a fundamental particle. We cannot see inside electron, but protons and neutrons are not. If the same way molecules are made of atoms, atoms are made of protons, neutrons, electrons. If you see a neutron or a proton, you see three more particles which are called quarks. So protons, neutrons are made of a more fundamental particle which we call quark. यहाँ पे हमारा जो अंडरस्टैंडिंग है यही पे खत्म होता है. अब when we explain nature at very larger scale, we use general theory of relativity. By the way, this description of fundamental particles and the fundamental forces, not gravitational force, but electromagnetic force, strong force, weak force, this together is called standard model. That was another word. That what is standard model? So standard model is what I just described. That a description of fundamental particles and fundamental interactions. So standard model tells us about subatomic particles, protons, neutrons, electrons. It tells us that protons and neutrons are made of quarks. Electron is not made of anything else. So I can think of electron and neutrino and protons and quarks as fundamental particles, not protons, quarks. But there is a problem in standard model. Standard model does not include gravitational force. And gravitational force का जो theory है वो general theory of relativity है. So if you try to combine standard model with general theory of relativity, these two theories are very popular, very accurate in their own domain. But any attempt to combine them has been proven to be futile. Why do we need to combine them? To explain singularity. जो हमने just पहले discuss किया थोड़ी देर पहले, that the center of black hole which is infinitely dense but also very small. To explain that, we need a theory which can explain general theory and standard model, which essentially is based on quantum mechanics. So standard model, quantum mechanics and general theory together, all these efforts have been proven to be futile. But that does not mean there have not been any effort. The most popular effort is called string theory. So string theory का जो fundamental, without going into again a lot of detail, string theory का जो fundamental notion ये है that what we think of quarks and electrons and neutrinos, if somehow we could see inside them also, we will find strings vibrating. And as those strings vibrate at different frequency, they produce different particles. So there is nothing called particle per se. Everything is simply vibration. Vibration of some, again, don't think of string how we think of string in our day-to-day life. This is a quantum string. It is only mathematical as of now. And as it vibrates at different frequency, it produces different particles. And those particles come in some combination due to some fundamental forces such as electromagnetic force or weak force or strong force, and they form atoms and molecules and matter. So string theory is a theoretical description of nature at the most fundamental scale, but it is only a theory. There is no way to confirm if any of it is true. Maybe it is entirely wrong, right? Maybe it is entirely correct, maybe it is partially correct, but we simply do not know that if it is entirely correct or if it is entirely wrong or if it is partially correct or partially wrong, right? So, but this is a description of nature called string theory, right? But हमारा जो अभी जो understanding है वो यहाँ तक limited है. The things are made of quarks and leptons. One of the lepton is electron. So this is what UPSC did ask all of these 4 words, and the answer here is observation and understanding of the universe. Any questions if you have? You can ask questions now. Not exactly the same thing. Ergosphere can be thought of as a lot of photons and particles swirling around black hole, very far away from event horizon. So event horizon का radius अगर r है, तो ऐसे समझ लो कि बाकी जो भी चीजें black hole के around जो exist कर सकती हैं without becoming part of event horizon, they will have to be like more than 4r or 5r. Think of बहुत काफी far होना होगा उनको event horizon से. Any other question? String theory? Sorry, question क्या था? So standard model is a well-established theory with a lot of experimental evidences. Many things are clear about standard model. String theory goes one step ahead of standard model. Standard model cannot explain few things. For example, standard model cannot explain gravity. String theory explains standard model and gravity together. At least in a theoretical form, it does the both things together. Is it correct or not? We simply do not know. Okay. बाकी क्वेश्चन अब आसान है. अब जो भी क्वेश्चन है वो इजी है. So let's look at some more questions. There is a question based on some of the famous experiments. Bell 2 experiment, blockchain technology, not experiment but technology, and CRISPR-Cas9 technology. But this was a very easy question because if you know that CRISPR-Cas9 is gene editing, then you do not have to even worry about the first statement. CRISPR-Cas9 is gene editing, not particle physics. Eliminate 3, you have your answer 2. And 2 is correct also. Blockchain technology is for cryptocurrency or can also be used for digital currencies in general. So 2 only is the correct answer. Bell 2 experiment is a particle physics experiment. ये जो particle physics यहाँ पे दे रखा है यहाँ पे आएगा. There is a very specific particle called meson particles, and Bell 2 experiment aims to understand more about meson particles. It is a setup located in Japan. This is the experimental setup of Bell 2 experiment, and this question should not be attempted if I change the question in the current pattern. How many of them are correct? So I know third to be wrong, I know second to be correct, but if I do not know the first, right, then that can be a problem. So that you have this 50-50 wala jo cheez hai. So that will be a little bit, not little bit, 50% risk. That will be 50% risk. That's totally up to you if you want to attempt or not. But in this pattern, this is a very easy question. Answer is 2 only. This was also a question inspired by current affairs. The word Denisovan, sometimes mentioned in the media, is in reference to an early human species. जो हमारा complete नाम है हमारे species का, वो है Homo sapiens sapiens. Homo sapien is the genetic group. Homo sapien, sapiens is our species name, right? But जो हमारा immediate larger classification जो होगा, I will call it this Homo species, or in fact Homo sapien species. So you have Homo sapien Neanderthals, or you have Homo sapien Denisovans. But turns out that those species did not survive. The Denisovans became extinct, Neanderthals became extinct. But we also know that in past Homo sapien sapiens, which we are, and Neanderthals and Denisovans, they definitely party together. How do we know that? Because in many parts of the world, when we do the genetic analysis, then we find Denisovan DNA. In Siberia, for example, the Denisovan DNA is 3 to 4%. Many Europeans have Neanderthal DNA of 2 to 3%. So it's very clear that even though sapiens and Neanderthals may have entered into conflict also, but they also lived together, right? And that genetic trace still is found in not across the humanity, but depending upon in which part of the world you are, there can be a chance of Neanderthal DNA or Denisovan DNA. So this topic often is in news because if you have found some early hominid species genetic sample and you do some genetic analysis, and based on that you try to learn more about our closest evolutionary ancestors, all of them have become extinct as of now. So the answer here is an early human species. This was one of the easiest question. Like 9th biology में पढ़ते हो, difference between plant cells and animal cells. Plant cells have cellulose, cell walls, whilst animal cells do not. Plant cells do not have plasma membrane, while animal cells do. Mature plant cells have one large vacuole, while animal cells have many small vacuole. The second statement is not correct. First statement is correct. Because of that cellulose wall, plant cells are rigid and plants cannot move. Since we do not have that, we are much more flexible and we can move. So first is correct, third is correct, second is not correct. जो plasma membrane structure है, that gives protection to all eukaryotic organism, चाहे वो plant cells हो, चाहे वो animal cells हो. So ये बहुत आसान question था. Here answer was 1 and 3 only. If you look at the structure here, right? So vacuole, that one large vacuole versus many small vacuoles. Plasma membrane, cell wall, that is absent here, but plasma membrane is present just inside the cell wall. Plasma membrane and plasma membrane here, that is present in both the cells. There are many more differences, presence of chloroplast, many other things, but UPSC did not even go into a lot of detail here. They asked a very simple question and eliminate second option, and you have your answer. Right, so there are many differences. Both have mitochondria, but only plant cells have chloroplast. Both plants and animals have vacuoles, but again there is a difference. Plant cells have a cell wall, animal cells simply have a cell membrane, but no cell wall. We know about these things. Okay, this was a fantastic question. For me, this is like one of the best questions asked by UPSC. And so many people got this wrong, right? We got it right. So I was very proud of that we got this answer correct. Many people thought that UPSC has given wrong answer after answer key was released, but they did not give the wrong answer. Like, their understanding is simply not accurate. This question is that in a pressure cooker, the temperature at which the food is cooked depends mainly upon which of the following. The first option is area of the hole in the lid, temperature of the flame, weight of the lid. Everybody gave the answer as D. We gave the answer as 1 and 3. The second is not at all true. Temperature of flame will not determine that what temperature inside the cooker food will be cooked. Exactly. So let me first explain. This is not that simple. Like, it's also simple if you understand the basic concept of thermodynamics. One of the goals of thermodynamics is to study the heat transfer. In a thermodynamic system, we divide universe into two parts. We first describe a system, and then we describe a surrounding. And then we see, for example, let's say I have to understand my energy transfer mechanism with the surrounding. I am a system, and the rest of the universe is surrounding. Then in thermodynamics, we will try to understand that what are the processes through which energy is being produced inside my body, and how that energy is being transferred from the surrounding. But is it only energy? Are we also transferring matter to the surrounding? So we divide our thermodynamic system depending upon, if you are neither transferring matter nor transferring energy, we call this isolated system. If you are only transferring energy but no matter, we call it closed system. If we are transferring both energy and matter, we call it open system. Right? So let me give an example of all of that. So for example, you can think of isolated system is very rare, but if you want to imagine isolated system, imagine some thermally resistant material kept into vacuum somewhere. Right? It's an ideal situation. Saying that something is completely isolated is an ideal situation. There are many open systems. Think of, for example, water in a pipeline. That this water is coming down, but this water carries energy. So the pura pipeline agar mera system hai, so matter is also coming out, energy is also coming out. But pressure cooker is an example of closed system. That in pressure cooker, most of the transfer which happens is energy. Matter transfer does happen when that CT jab upar jayega, then that gas does come out. But most of the time, the thing which is being transferred between the system and surrounding is essentially energy. Okay, so what is the source of energy? Source of energy is that flame. That हमने gas चूल्हा को जलाया, flame is at some temperature, and that provides the energy. अब flame temperature खाली ये decide करेगा कि जो अंदर का पानी है वो कितना जल्दी vaporize हो गया है. बट वाटर का जो बॉइलिंग पॉइंट है वो डिसाइड होगा कि अंदर प्रेशर कितना है, और अंदर प्रेशर कितना है ये इस बात पे डिसाइड होगा कि फ्लेम टेंपरेचर कितना है. अंदर प्रेशर कितना है ये इस बात पे डिपेंडेंट होगा दैट ओवरऑल आपका लिड कितना हेवी है. इफ लिड इज वेरी हेवी, सो प्रेशर कुकर पहले तो काम कैसे करता है देखो. प्रेशर कुकर इज अ क्लोज सिस्टम. इट इंक्रीजेस द प्रेशर इनसाइड दिस कुकर, एंड बिकॉज ऑफ दैट वी नो दैट बॉइलिंग पॉइंट ऑफ वाटर इज अ फंक्शन ऑफ टेंपरेचर बट आल्सो प्रेशर. दैट एट हाई प्रेशर द बॉइलिंग पॉइंट इंक्रीजेस एंड एट लो प्रेशर बॉइलिंग पॉइंट डिक्रीजेस. पहाड़ों के ऊपर चले जाओ, वाटर जो है 17 डिग्री सेल्सियस पे बॉइल हो जाएगा. यहाँ पे वी नीड 100 डिग्री सेल्सियस. व्हेन आई से 100 डिग्री सेल्सियस देन आई assume 1 atmospheric pressure, and if you are on the surface of earth you can assume 1 atmospheric pressure, no problem there. But inside a cooker that pressure is very high, and inside a cooker the boiling point of water goes as high as 121 degrees Celsius. So the cooking actually is happening at very high temperature. That water is at very high temperature, but it's not escaping. It's still water. It's still liquid, right? And liquid at high temperature will carry much more energy. Gas will spread. So you have created a closed system where pressure is very high, and because of that, boiling point of water is very high, and your food gets cooked easily. But वो pressure regulate कैसे हो रहा है? Pressure regulate हो रहा है आपका जो vessel है उससे. कि अगर pressure infinitely बढ़ जाए तो पूरा फट जाएगा. We do not want that to happen also. Pressure maintain भी तो करना पड़ेगा ना. If we do not allow anything to escape, if I allow all of the water to convert into gas, and then this gas is heating up, then it will increase the pressure so much that the entire cooker will burst. That is why to regulate pressure I need that vessel. Area of hole in the lid. If that area is very large, more gases will release, and that will decrease pressure very, very fast. If the area is less, it will release less gases, that will decrease pressure slowly. Weight of the lid. If that weight is very heavy, lid is very heavy, lifting up that lid will be much, much more difficult. If that weight is very less, lifting of the lid will be easier. So that weight of the lid and this area of the area of hole in the lid, that actually determines the pressure which is inside this cooker, and that pressure determines that what temperature water is going to boil. That flame temperature only determines that how fast this water will vaporize. That's it. But जो pressure अंदर कितना built है वो flame temperature decide नहीं कर रहा है. That inbuilt pressure is being decided by the area of the hole and the weight of the lid. So that is why second is not correct. The answer is 1 and 3 only. So this was a very simple concept of thermodynamics where you have to appreciate that pressure cooker is a mostly closed system, and the temperature, because question ये नहीं बोल रहा है कि खाना आपका किन parameters पे depend करेगा. Question ये है कि temperature at which the food is cooked, which essentially is boiling point of water here, ये कौन से parameter पे dependent होगा, ये question है. And ये temperature जो है that is decided by pressure inside the cooker, and that pressure inside the cooker is decided by that hole in the lid, and the weight of the lid. It is not decided by flame temperature. That is why second statement is wrong here. Answer is 1 and 3. C is the correct answer. I'm not saying without temperature. Question is कहाँ question बोल रहा है कि without temperature है. Question ये बोल रहा है कि आपने flame को बढ़ा दिया, temperature बढ़ा दिया, flame को कम कर दिया. ये बस ये करेगा कि आपने कुकर में जो पानी रखा था, पानी कितना जल्दी vaporize हो गया. Like अगर flame temperature ज़्यादा है तो पानी जल्दी. Question is not asking how fast or slow it will be cooked. देखो अब यहाँ पे confusion क्यों है? Why some people thought that this question यहाँ पे second true होना चाहिए. Question पूछ ही नहीं रहा है कि कितने जल्दी या कितनी देर से खाना बनेगा. Question ये नहीं पूछ रहा है. Question पूछ रहा है कि कितना temperature पे खाना बनेगा. और बस ये है कि अगर मैंने flame temperature को बहुत कम कर दिया तो जो भी मेरा water है उसको vaporize होने में ज़्यादा time लगेगा. But जो pressure अंदर कितना built होगा, that is decided by how much steam is there inside that particular cooker, and how much steam will be there, that is decided by that weight and that area of the hole. So flame temperature will not play a role here. Right? So question is not asking how fast or how slow food will be cooked. It is more about that at what temperature the food will be cooked. And because of that, answer is 1 and 3. So that is why I said that reading that question carefully is very, very important. This is a very simple question of biology. Which of the above can be cultured in artificial synthetic medium? इसमें बस हमको एक चीज ध्यान रखना है कि जो वायरस है, वायरस is considered as a bridge between living and non-living. Virus is not considered a living organism because it cannot multiply all by itself. Viral cell जो है, it cannot lead to cellular multiplication all by itself. But it is also non-living. It is also not non-living because when it infects some other organism, that other organism can be a bacteria, that other organism can be some other parasite, it can be a plant, it can be an animal, it can be a fungi. But when it infects some other organism, it hijacks their cellular machinery, and then it uses the cellular machinery of the host to multiply. And then it multiplies very rapidly, it grows exponentially. Right? So In an artificial synthetic medium, you simply cannot culture virus because it is not possible to do that with a host. If you want to replicate virus in a lab setup, then use some bacteria, use some fungi, use some plant, infect them. Take a bacteria, infect them with a virus, and bacteria को multiply करो. Bacteria multiply होगा, virus multiply होगा. But ये again हमको living organism चाहिए to do that. We cannot do that in some non-living artificial synthetic medium. So that is why third is not correct. Answer is 1 and 2 only. But bacteria culture and fungi culture ये बहुत popular चीज़ है. Bacterial multiplication, fungal multiplication, इसके करने के बहुत तरीके हैं. Some people, I should tell you this. Yeah, I should tell you this. That some people interpreted that artificial synthetic medium, including that, let's say in a petri dish I have bacteria, and I have infected the bacteria with a virus, and then I'm multiplying bacteria, hence I'm multiplying virus, then will it be considered artificial synthetic medium? Right. So some people did interpret this, and I often feel the people who actually did interpret this is that they had medical sciences background. That they knew more about the topic. Right. So I often feel like that sometimes this over analysis can also be a problem. Right. So but nonetheless, ये थोड़ा सा, I will not say that ये बहुत ज़्यादा controversial statement है, थोड़ा सा controversial है. But artificial synthetic medium जब भी हम ये word use करते हैं, then essentially we talk about that ideal condition of light and nutrition and everything. Bacteria को multiply करना है, plant buds को multiply करना है. तो एक ideal condition हम provide करते हैं, जहाँ पे चीज़ों का multiplication बहुत high rate पे हो. That is the meaning of artificial synthetic medium. Virus कोई भी ideal condition आप provide कर दो, if there is no living host, it is simply not going to multiply. So hence third statement is not correct. This is another fantastic question. Also very simple question. Water can dissolve more substances than any other liquid because it is dipolar in nature. Water is one of the most amazing molecules, perhaps in the known universe. It is the simplest but the most amazing molecule. Let me tell you why. Water is made of hydrogen and oxygen. Hydrogen goes into liquid at minus 253 degrees Celsius. Oxygen goes into liquid at about minus 193 degrees Celsius. And both of them come together, make water, which becomes liquid at 0 degrees Celsius. Right. Above 0 degrees Celsius it is liquid. Below 0 degrees Celsius it is solid. That in itself is quite remarkable. But hydrogen oxygen are बहुत simple molecule है. बहुत सारी चीजें नहीं, बहुत simple molecule है. It is a covalent bond. It is a covalent bond. But covalent bond में क्या होता है कि electron is shared between two things. If there are two molecules, then electron is shared among two molecules. The problem here is that अगर ये दो molecule या दो atom अगर O और O रहता, O2 रहता, तो ये oxygen atom दूसरा oxygen atom दोनों का जो electron affinity है, that it wants to pull electron towards it to gain stability, that is same, right? So there will not be any charge distortion in O2 or N2. But in H2O, so I have O and I have H. So in H2O, this O has more tendency to attract electron to what? We use a parameter called electron affinity. So oxygen has this higher electron affinity compared to hydrogen. So even though this electron is being shared among oxygen and hydrogen, this oxygen and hydrogen, this electron cloud is more towards oxygen, and because of that, there is a very small negative charge here often shown with delta minus, and there is this very small positive charge here shown here with delta plus, which makes water bipolar. But the amazing part here is that because it is bipolar, now think of this oxygen molecule which has this less electron towards it, and think of some other water molecule, HOH. So now they make a hydrogen bond, a very simple weak bond, but they make a hydrogen bond. And if I put something else which is also polar, such as let's say salt, salt is a simple example. Anything which is not homonuclear atom, such as O2 or N2, will be there will be some polarity. So if I put something, any polar substance, then this negative oxygen will bond to the positive part, and that positive hydrogen will bond to the negative part, and that object will dissolve. So hence the answer is actually very simple. It is dipolar in nature. And since many of the materials which we use, they also have some polarity, they're going to dissolve very, very easily in water. So correct answer is A here. Water has more amazing properties. I've only talked about few of them, but it has more amazing properties. This I would say is a little bit difficult question. Like you had to know about few things, and only then you can answer this question. The question is, with reference to street lighting, how do sodium lamps differ from LED lamps? Sodium lamps produce light in 360 degree. It is not so in the case of LED lamp. अब ये इसका क्या मीनिंग है जब तक अगर आपको क्लियर नहीं है तो फिर ये क्वेश्चन आप नहीं कर पाओगे. एक टिपिकल जो लाइट बल्ब हम यूज करते हैं, दैट लाइट बल्ब इल्यूमिनेट्स लाइट इन ऑल डायरेक्शन, सो इट कवर्स दैट 360 डिग्री. एलईडी का देखो सबसे बड़ा फायदा क्या होता है कि जैसे मान लो अगर मुझे इस रूम में लाइट चाहिए, एलईडी लाइट है, तो हमको लाइट यहाँ पे चाहिए, हमको पूरे रूम में वहाँ पे कुछ और एलईडी लगा देंगे. ऐसा तो है नहीं कि हमको पूरी जगह लाइट चाहिए, हमको क्लियरली ऊपर नहीं चाहिए, साइड में नहीं चाहिए, साइड में ज़्यादा लाइट की जरूरत नहीं है. सो एलईडी विच इज लाइक दिस वेरी स्मॉल रेड ब्लू ग्रीन टुगेदर, illuminating together in the same intensity producing white light, हम इसको इस तरीके से डिजाइन कर सकते हैं, all of this very small red blue green, that they can direct their light in a specific direction. And I can make LED which can produce light only in 90 degree. I can make LED which can produce light only in 180 degree. So now imagine what is happening here. ये लाइट बल्ब जो है मान लो 10 वाट का था, it was illuminating entire room, but I can produce the same light if I only want 90 degree by 10 by 4 light, and if it is 180 degree I can do the same thing with just by 10 by 2 wattage. So LED becomes more energy efficient. LED consumes much less energy compared to any other type of bulb which we use. पहले जो बल्ब हम यूज करते थे तो और भी खराब था, तो literally was because of heat is producing into light, it was loss of a lot of energy. But even other bulbs like LCD or sodium light bulb, these things they still are not that energy efficient. LED is. So ये सही है. The sodium lamp which produces this yellow light, it produces in 360 degree. LED can be directed 90 degree, 180 degree, 120 degree, and we can arrange LED to do that. At street light, sodium lamps have longer lifespan than LED lamps. अब इसको eliminate करना आसान था. This was not a difficult statement. Like the moment you read about benefit of LED, the first benefit you read is high energy efficiency, and the second benefit you read is longer lifespan. So while all other bulb will become wasted very soon, LED bulb often will have twice, thrice, 4 times, 5 times lifespan. So that is another benefit of LED compared to all other bulbs including sodium lamps. So second is not at all true. Eliminating second was correct, right? So if I know second to be wrong, then I can get this A and C to be correct. I know that either A is correct or C is correct, which also tells me that third statement is correct, right? But I still have to know that first statement. So that is why I thought that this is a little bit difficult question, that you should know that LED can be directed in a way that जो पूरा light है एक 90 degree 180 degree में produce कर सकते हैं. So and that is why that makes this question a little bit difficult. Third statement is, even though this statement is also difficult, but my answer is not dependent upon this statement. That spectrum of visible light from sodium lamp is almost monochromatic. Sodium light, अब ये थोड़ा सा यहाँ पे they went into technicality of things. Sodium lamp produces two wavelengths, and the two wavelengths, both of them are separated by only about like few angstrom, I guess 5 or 10 angstrom. I also have forgotten. But since that wavelength difference is so less, I can assume it to be monochromatic. So, and by the way, they're saying that it is almost monochromatic. It is also not saying that it is exactly monochromatic, but it produces two wavelengths. Monochromatic का मतलब होता है only one wavelength, and almost monochromatic का मतलब है that if there are wavelengths, they're not very far away from each other. They're very close to each other. Sodium produces this yellow color wavelength. Both of them are very close to each other. LED lamp offers significant color advantage. That is very simple. Red, blue, green. I can have either red, either blue, or green. Illuminate all three of them in same light, same intensity. I have white. But change their intensity, I can produce all the possible colors, which we know. These are three primary colors, and with help of these three primary colors, I can produce all other colors. So third part is this part is true. The LED lamps offer significant color advantage in street lighting. So first is true. This third is true. Second is not true. Answer here is C. Right? But knowing that first was important here. Only then you could have get the answer correct. This is earlier topic which I already have discussed. Which one of the following is the reason why astronomical distances are measured in light years? That is a direct consequence of special theory of relativity. That speed of light remains constant in all frame of reference. So since speed of light does not change, if I use this distance, that in 1 year, how much distance light travels, I call that distance light year. Light year is a measurement of distance. So correct answer here is D. Speed of light is always same. Why some people got confused? Distances among stellar bodies do not change. ये तो clearly wrong है. ये तो बिल्कुल सही हो नहीं सकता. Gravity of stellar bodies does not change. First of all, that is wrong, and second of all, it doesn't even matter. How does that explain velocity of light? But in any case, it is also not correct because sun का mass बहुत heavy है, but sun gains and loses mass, mostly loses mass. Light always travels in a straight line. अब यहाँ पे देखो, ये वैसे तो correct है, except affected by gravity, but even then it is not an explanation of that why we are using light year as a unit of distance for astronomical distances. That even though most of the time it is correct, that's also not a problem. Why some people thought that D should also not? I remember talking to many students and many of them had marked C as the answer. And why they thought D to be wrong? Because they thought that light तो bend करता है, और light का जो speed है वो तो water में कम हो जाता है, light का speed glass में कम हो जाता है, तो galaxies के बीच में water नहीं है, galaxies के बीच में glass नहीं है. So I can easily assume that the distance, astronomical distances do not have denser medium, right? And even in air, by the way, air is not vacuum. Air जो है atmosphere है, it is not exactly vacuum. But even within air, velocity of light is almost 3 lakh kilometers per second, right? So I can easily assume that velocity of light, by the way, it is always same in all frame of reference. It only decreases in a medium. But for astronomical distances, we do not have to worry about that. So that is why correct answer is D here, right? So speed of light is always same, a consequence of Einstein's special theory of relativity. That explains the answer to this question. Universe is really huge. Sunlight takes 8.3 light minutes. Proxima Centauri, the nearest star, is 4.3 light years away. The nearest galaxy, Andromeda galaxy, which you can see from your naked eyes. That is the farthest object which you can see from naked eyes. Andromeda galaxy देखने के लिए आपको लद्दाख वगैरह जाना पड़ेगा, दिल्ली से नहीं दिखेगा. But if you go to places where sky is very clear, one part of the sky will be dense with star, and then there will be some empty part of the sky, and then you'll see a light, dispersed light. It will not be a star, but you'll see like not exactly one star, but a spread light source somewhere in the sky you can see. That actually is not one star, but that is Andromeda galaxy, which is a bigger galaxy than Milky Way galaxy. But Andromeda galaxy is 2.5 million light year away. Right? Anyways, this is about light years. This was a question asked this year, 2024 का question है. This is one of the questions which I consider, even though it is a question of science and tech, it is very factual, and only those who have very good knowledge of biology will be able to answer. But it's a good thing then that you simply have to skip such questions. इस question को attempt करने का कोई meaning भी नहीं है. And ऐसा भी नहीं है कि जैसे मान लो आपने बचपन में कभी पढ़ा था कि कोई तो oxide of nitrogen था, but उससे भी आपका आंसर नहीं होगा. All oxides of nitrogen are given. NO, NO2, N2O, N2O5. All of the molecules are oxides of nitrogen. So correct answer is NO here, nitric oxide. That NO, even though is a pollutant if consumed in very high amount, if you inhale NO in very high amount, is a pollutant. Your body does produce that in very small amount, which essentially dilates your blood vessels. It allows more blood flow to occur, and it reduces the stress on our arteries and veins. So it's a good thing that your body can produce this very small amount of NO. So, but this is a very factual and a core question of biology, like understanding of human body, and only with students with like proper background in the topic will be able to answer the question. Right? So answer is A here, and I will repeat that in such questions, do not try to be smart. Like for example, अगर आप smart बनने की कोशिश करोगे, तो आप नाइट्रोजन पेंटॉक्साइड मारोगे, because आपने NO, NO2 पढ़ रखा है, ये तो pollutant है, N2 आपने पढ़ रखा है, ये तो greenhouse gas है, laughing gas भी है, so then you'll say that N2O5 ठीक लग रहा है, right? So you'll mark that as the correct answer, but that will be wrong, of course. चलो, let's take a break here. After that, we will discuss this next set of topics from space technology. Then we will discuss biotechnology, health, and ICT. इस तरीके से progress करेंगे.
Does the vast syllabus
Crop productivity, locating groundwater resources, mineral exploration, telecommunication, traffic studies. And then there was a very similar question in 2019 for the measurement estimation of which of the following are satellites images, remote sensing data used, chlorophyll content in vegetation, greenhouse gas emissions from rice paddies, land surface temperature of a specific location. Remote sensing satellites are a very powerful tool. If you have an atlas, then we will map about risk. Then those maps were prepared with help of or map about forest cover, forest resources. So except the political map, in fact, even in political map, except that political map, all other maps which you have in your atlas, lot of input in preparing that map must have been taken by remote sensing satellite data. So remote sensing satellites essentially equipped with a lot of optical instruments, and these optical instruments take images of Earth's surface. But you should not think of them as a very simple camera. That blue and green. So there are remote sensing satellites which do very powerful optical imaging. They're also taking image in red, blue, and green, of course, with much wider area and much higher resolution. But imaging is not only optical imaging. There is all thermal imaging. As objects heat up, they radiate infrared radiation. And then there are satellite sensors which are capable of capturing that infrared, which will tell you the heat map of the world. So for example, this imaging will be very helpful if you have to, let's say, understand volcanic eruption, or let's say if you have to understand impact of global warming, that sea surface temperature is increasing, or let's say you have to understand urban heat island effect. Urban heat island effect, आपने environment में that urban areas का जो temperature है ज़्यादा है compared to the surrounding. So in thermal imaging, urban areas will appear to be brighter. So it's no longer a theory. We can actually confirm this, that the urban area's average temperature is more compared to the surrounding with help of remote sensing satellite. We can do radar imaging. Radar imaging is in fact using radio waves, not even visible light or infrared, but using radio waves. Now the thing with radio waves is that they are not naturally occurring. So you have to first produce them, and then you measure the reflection. जैसे think of this like how a bat navigates or how a dolphin navigates. पढ़ा आपने bats and dolphins के बारे में? What is the technique they use? Echolocation. That echolocation essentially is nothing but a sonar technique. What a bat does or what a dolphin does is that they produce sound waves, ultrasonic sound which our ears are not capable of listening. And as that sound gets reflected from the objects in front of them, how much sound was reflected, how much was absorbed, how much time it took for that sound to be reflected, based on that, they have a very good awareness about their surrounding. Just say, I have a very good awareness about my surrounding with help of light. Just say, I can see that you guys are sitting in the front, you are at the back. So light allows me to see all of you. But it not just allows me to see all of you, it also allows me to distinguish all of you. It allows you to understand me, to understand the color of clothes you are wearing. It allows me to understand the distance of this class, people who are sitting at the back, people who are sitting at the front. Light carries information with it, but even sound carries information with it. Dolphins use sound waves to see the world. How dolphins see the world, we will never know. Right? But we can use this in a technology. That is what ultrasonic technique is used in pregnancy, to know about unborn babies. पढ़ा होगा आपने ये तो सब सुना होगा that we use ultrasound. Right? So X-ray imaging हम करेंगे. X-ray is dangerous radiation that can damage tissues of unborn baby. So we use sound imaging. We use ultrasonic technique to know about the movement of unborn baby inside the tummy of mother. So when we do radar imaging, we use a similar principle, but rather than using sound, we use radio waves. And the best part about radio waves is that radio waves, so जो radar sensors होंगे, let's say there is a satellite equipped with radar sensor. Radio wave का full form is radio detection and ranging. Sonar का जो full form है वो है sound detection and ranging. Radar का full form is radio detection and ranging. So satellites which are equipped with radar sensors, they will first produce their own radio wave. And how much time it took for that radio wave to be reflected by various surfaces, that will allow them to create a very good map about the objects and about the surface of Earth. And the benefit of using radio wave is that radio wave can cross through many things which visible light or infrared cannot, particularly cloud. So cloud, rainfall, इन चीजों से radio wave को कोई ज़्यादा फर्क नहीं पड़ता. I will not say कोई फर्क नहीं पड़ता, but these things affect visible light or infrared much more. Particularly visible light is affected a lot. If there is, let's say, dense cloud, but radio wave can cross through that very, very easily. So radar imaging allows you to see things even when optical imaging is not allowing you to do that. So there are many remote sensing techniques. And the best part of light is that light only not just tells you the distance or the color or the physical features, it also tells you the chemical properties. That only by analyzing the pattern of light, just for example, we see that leaves are green. Why are leaves green? We have learned that. That is the color which leaves are reflecting the most. But why are they reflecting that color the most? Because for photosynthesis, green is not useful. For photosynthesis, blue is much more helpful. Yellow is much more helpful. So the chlorophyll molecules, they absorb that blue and that yellow a lot, but they do not absorb green, and green gets reflected. The point I'm trying to make here is that what type of light will be absorbed and what type of light will be reflected and what type of light will be emitted and what type of light will be scattered, all of that depends upon the atomic and molecular composition. Carrot looks orange because of carotenoid molecule. Carotenoid reflects orange color the most. The point I'm trying to make here is that light not only carries the information about distance and color and size and shape, it also includes the information about the atoms and molecules it has come in contact with. And there is a branch in science called spectroscopy, which does precisely this, that it analyzes detailed pattern of light, and based on that, it tries to understand the atomic and molecular structure of things. So now you can appreciate that your answer will be D. That remote sensing satellite data, it can measure the chlorophyll content. That green color जहाँ से सबसे ज़्यादा वहाँ पे chlorophyll है of a specific location. In fact, this is the data which is used to measure the green cover. Many things are done, but one of that is chlorophyll content. But greenhouse gas emissions are again nothing but molecules. These are carbon dioxide, methane, N2O, nitrous oxide. So from a specific location, again, we can do that also. And third, we can always do temperature. We can always measure with help of thermal imaging. Will be very helpful in measuring the temperature of Earth's surface. So answer is 1, 2, and 3. The point you need to remember is that light carries a lot of information. You simply have to know how to decipher that information. So some information is very obvious for us to appreciate. That the distance, I know that this chair is here, that chair is far away. Why do I know that? Because the light reflected from this chair reaches to my eyes much faster compared to that light, and my brain knows how to distinguish that, right? But spectroscopic devices can also answer questions like why I'm wearing a pink shirt. So why this color is pink or why some other color is green, right? And we can actually know about the atoms and molecules, about the fabric we are wearing, what type of chemicals were used to dye this shirt versus what type of chemicals were used to dye some other shirt. We can determine that with spectroscopic analysis. So remote sensing techniques, spectroscopy is very powerful technique. Answer here is D. But in that earlier question, remote sensing data allows you to measure moisture in soil, pest attack of a crop. Overall for soil monitoring we use this. आप एक अगर आपको देखना है तो एक इसरो एक पोर्टल मेंटेन करती है, वेदास पोर्टल, एंड इसरो एक और पोर्टल मेंटेन करती है, भुवन पोर्टल. Just go and explore these two portals maintained by ISRO, and you'll get the idea about remote sensing information I'm talking about. So first is correct. We can also locate groundwater resources, not directly. जहाँ पे भी groundwater बहुत ज़्यादा होगा, वहाँ पे जो surface characteristic है, जो soil characteristic है, that will be different. So remote sensing data will provide you this indirect information about the probability of aquifers, and that will allow us now to do, let's say, on ground exploration, that the extent of natural aquifers. Aquifer mapping के लिए, groundwater resources को locate करने के लिए, again we can use remote sensing data, and this we already do. जो आपके map में जो resources वाला map है, lot of that is because of remote sensing data. This we do not do because remember there is a separate type of satellites called communication satellites, which are used for telecommunication purposes such as radio and television. That is not the purpose of remote sensing data. If I know 1, 2, and 3 to be correct, 4 to be incorrect, then I know my answer is A here. The problem is this option. That can I use remote sensing data for traffic studies? The answer is yes, I can. Are we using Indian remote sensing satellite for that? 2015 तक तो नहीं कर रहे थे. 2015 का क्वेश्चन है. हो सकता है कि पिछले 10 साल में कुछ लोगों ने, कुछ IITs ने, हो सकता है जो ट्रैफिक स्टडीज करते हैं, they might have asked government of India to share the data of remote sensing, and they might be using this for traffic studies. So it is possible, but are we using it? Is ISRO using it? ISRO is not using it for traffic studies. That I know. I have explored